friends, welcome back to online course Structure, Form and Architecture, the Synergy. Today we will talk about lecture number 5, that is synthesis of architectural and structural form. So, before I start today's lecture, so far whatever we have covered, we have seen that structural form they helped to make architecture to fulfill the concept and also bring some architectural visual qualities. And also we discussed different kind of loads in our previous lectures, where we have seen like starting from the dead load, live load, then different lateral loads, seismic load, etc. So, in this lecture we will basically focus on different structural form and how they are making a strong correlation with architectural form creation. So, we will pick up some of the major and predominant structural form that being used to create some world class architecture and in the modern world. So, gradually we will also see like take some examples from the history where other kind of structural form being created to bring the architecture. So, let us start today's lecture. Here we again like previous lectures we just look into the definition. So, what is the form? Already we have discussed it. The form is basically the visible object, okay, and we define it with a shape. So, it is a definition given by Francis D.K. Ching. So, what exactly it is? Let us have a look into this. Form is generally and primarily understood as shape or three dimensional massing. Okay. So, one object having three dimension that will give a sensation to our eyes and we see that object as a form, but also encompasses additional architectural aspect. So, it is not like a very dull three dimensional shape, but in order to make it and give a term called architectural form. So, it also have different aspect like space creation, then different arrangements including structural configuration, and this is obvious after initial few lectures. Now, we all agree that in order to give the form of architecture, structure is indispensable, means it is very much needed. Without structural stability, structural support, we cannot create the form the way we want, which may organize and unify architectural design. So, basically form by this definition, if we simplify this, so it is three dimensional object. Along with that, it will have some architectural aspect, it should have some space to live in order to maximize your utility, and also this should be supported with some structural configuration, and finally altogether it will basically create and unify an architectural design. So, with that we move forward to the architectural form. So, here it says architectural form is an inclusive term that refers preliminary to a building external outline. Here this is very important, external outline or shape. So, whatever the form we normally say, so basically most commonly we refer to the outline of the building. If a building is something like that, so we say it is a domical form of architecture. What is inside the space essentially we do not say about that, and to a lesser degree reference to its internal organization, as already I mentioned, like in order to create architecture we have to articulate spaces. So, it will have a relationship between different space, their transitional space, how we connect to space. So, that is very important for creating good architecture, so that our purpose to create will be achieved. But when we discussed about the form, so basically it is whatever the overall shape being created and basically the outline. But sometimes also we also observe the internal form. Sometimes I have given one example of Pantheon, where it is looking very beautiful from the inside, that your domical form that we have seen. So, one thing is very clear, it is giving a shape or outline. Now, in this shape is basically creating a visual representation, and that also having some property of the size, color, texture, position, orientation and visual inertia. So, these all are very important thing, like whether my structure will be in human scale or in monumental scale. So, in I guess that in like who have studied the history of architecture. So, earlier we have seen that like many examples which the architecture is in monumental scale, the huge structure. So, size is something very huge, and sometimes it is nowadays with the age of shortage of space and all, sometimes we actually optimize the space. So, with the minimalistic form and small size. Now, to the color, definitely it will give a contrast to the background. So, whenever we see any image or who are like having like some interest in photography, they also capture a frame. So, in the frame we have a background and one foreground, and with different color contrast created. So, sometimes the architectural form is very simple rectilinear, but the color used through the material or maybe paint can create something different. Texture, obviously we have discussed that sometimes it may be rough, sometimes it may be very smooth like glass. So, this is important, the position of that. Now, based on the position, how you place your form one after another, how you make composition, that will actually give you a different sense. Orientation, it is again very important, not only for the aesthetic purpose, but also sometimes in order to tackle with the lateral load. If you can recall the wind load, that we have seen that when we place this rectilinear form and this is the prevailing wind direction. So, this create thrust. In order to that, if I just rotate a bit, so we can minimize it in that, and visual inertia is very important, that will give a visual sense of stability. We have seen some of the buildings in our previous lectures, that where we have seen that the building is following the stability, visual stability is there, and sometimes it is not. So, it refers to the instability, visual instability to that. So, these are the properties of a form that will make one architecture from other. Now, come to the structural form. So, form is shape. Now, how to really distinguish between architectural form and structural form, that is the question. So, here structural form is the primary or most visually dominant structural system of a building. Okay. This statement is not really giving a very comprehensive answer to us. So, what exactly it want to mean? So, so far we discussed that the shape is a 3-dimensional thing. Then in order to make it architectural form, so it should have some some space and other thing to call it architecture, and then basically architecture is the outline of that architectural design. This shape, this outline is your architectural form, whether it is in rectilinear form or in any sub curvature or something. Now, structure is basically the backbone of that, the dominant structural system. Now, here we should be careful. So, when we say the dominant structure, what exactly? Like by looking at the building, you will just get to know that okay, this structural system is of this kind. But sometimes even rather most of the cases, a building may have more than one structural system. One to just give the structural stability, other may to give some other facilities. So, which system is visually dominant, that is a question. So, which form will take? A building may have arch form some part of the building, and somewhere it is just beam column structure. So, there which form should we take? So, concept of structural form is unhelpfully simplistic. So, basically when you say structural form, it is rather to say this is the structural system. So, when we say structural systems, then we have some category into that. So, we can classify our structural system in many ways. So, one way of classifying it with the overall shape of 3-dimensional shape and other thing. But structural system can also be defined with other parameters like its nature, whether it is like your compressive structure or it is your tensile structure or so on, or else we can also define it in other terms like your supporting structure or supported structure. But in this particular lecture we will not discuss those, we will come to that in some future lectures, but in this primarily we will focus on the structural form based system. So, I will just make it clear with certain example. Say for example, if you see a building making of such concrete or steel member, and the form being created is simplifying or simply say it is an arch. So, this is basically the form, but again this system, whether it is like your tensile or it is compressive or something, will touch upon those issues and we will discuss one by one in our future lectures. So, let us move on to the concept. Again this is very important and very interesting slide. So, here the structure can be defined with 4 S: strength, stiffness, stability and synergy. So, what is strength? So, basically strength is some property by which you can prevent breaking. Okay. So, if I having a beam which is having good strength, maybe made of good quality concrete, so it will resist more load. So, it will stop from breaking, but at the same time, say for example, I take these pen examples. So, it is made of some material having some kind of strength, but not as compared to concrete. So, if I put pressure on that, it may break. With pen it may take some time, but if you do it with a chalk, maybe as because of its brittle property, it will break even earlier than this one. So, strength is very important like property of a structure. So, depending on the load, also we have to be choosy about selecting material having the proper strength, which will help to prevent from the breaking. You can see this schematic where this is a beam and supported by 2 columns, and when a load is applied showing by this arrow, so it is breaking. So, if you make it strong, then it will. But regarding this, I just want to highlight another important issue. We will also come to that later on, but as because now we are discussing this. Say for example, when we make a slab resting on column. So, basically if you know this is particular section. Now, in this case I just zoom it. So, suppose this is made of concrete and made of PCC. PCC stand for plain cement concrete. So, there is no reinforcement. Now, because of the self weight and also some live load of furnitures and then people, so it will have some bending. Okay. And what is happening here? So, if you want to see this section, so the upper portion will have one type of load, that is like they will have the compression. Okay. So, this particular portion will try to contracting to each other, and this portion will try to expand. So, tension will be developed here. Now, for that reason it will collapse from the bottom. In this case, because load is applied from the top, if I apply load from the bottom, so it will first develop crack in the upper section. And let me tell you one thing, the like concrete, like plain cement concrete. So, basically the property of concrete, it is having good compressive strength. So, in compression it will sustain, but not in tension, but tension developed at the bottom. So, in order to overcome, we have to support it, we have to reinforce it with some material having higher tensile strength value, and that is why we put reinforcement. And the reason for this kind of slab, we put the reinforcement in the lower side of the section, okay, so that this will take care of the tension. So, it will give a balance with tension, compression, and finally, we will have some equilibrium. So, we will come to that and we will discuss with some experiment also, but anyway. So, to make it sometime stronger, having good strength, we may look for some combination of different structural material. Now, come to steepness. Steepness is a property which will prevent the excessive deformation. Say for example, if it will not have this much of steepness, so it will deform, and the time like if you create some structure having higher deformation, which will not be really a good sign, because then your whole structure, the supporting structure or the supported structure on this column may act in a different manner. So, this is another property which is very important to select about the structure. Now, come to stability. Stability will depend on the arrangement of your structural element. We have given one example like your pyramid and inverted pyramid. Okay. So, depending on the arrangement, because of the lateral load and other thing, so stability is basically prevent the collapse. So, if arrangement is something like that, we make a composition something like this is one, option number 1, and I just make option number 2 here. Okay. So, when we arrange this cuboid one after another, so this is option number 1, this is option number 2. Now, my question to you, looking at these two and consider the same material and all, which structure is considered to be more stable? So, I am sure that all of you agree that one is much more stable than 2, because of the mass and other thing, and that is why those points where it get connected is very crucial. Now, we have discussed the activity during earthquake. So, there will be some lateral movement in both the direction, horizontal direction, left, right, and upward, downward. So, in that case, basically those joints are very critical, because here you just represent it in the real case. So, this is slab and this is a beam, or there will be some column and also those joints should be casted adequately, proper care should be taken, so that during that movement this structure will act as a monolithic structure. What is monolithic structure? Made of, say, similar one could single material. Sometimes the cave, we consider the rock cut cave and all, they are monolithic structure. So, that all will have the motion, so that this building will be stable. But though we have good strength material having the steepness, the property, and also the arrangement and assure the stability, but then also there is something which is very important to bring the result as per our requirement, that is the synergy, and that the all subject, the whole course is all about the synergy between different structural element. So, if you want something to be very strong, stiff and also stable, so you must have a good synergy between those materials along with the design elements. So, that we cannot compromise our requirement, at the same time we should not compromise the structural safety. So, that my structure will be visually pleasant, structurally strong and having a good durability, it will stay for longer. So, this is something is very important, and looking into this concept, sometimes we have to reject some of the structural form which may not be applicable for our design. So, in upcoming slides what we will see basically the synthesis between architectural form and structural form. So, looking at that, basically it will give a sense of a shape through dimensional shape, but at the same time it is being so well designed, it is giving the architecture the way we want, and also the structural form that support that to bring it into reality. So, let us move forward. So, here we have listed 8 such structural and architectural form synthesis, and we will see by with some examples, some photographs from different parts of the world and especially the modern architecture. So, one is your cell structure, second one is fabric structure, catenaries is one of them, then you have rib structure, then arches, folded plate, frame structure and walls. This list can be further extended and we will also do that, and we discuss some other kind of structure like pneumatic structures and other form of shape that we use and structural element we use in architecture. But before we again proceed further, let us understand by the term what is shell. So, basically I can give you example of egg. So, what exactly it is? The white outer shell is having enough strength, and in some of the experiment it has been shown that it may take up to even more than 20 to 22 kgs load. So, this is very thin, is so brittle, and who are having eggs in their daily menu and all, they know that when you break it for the omelette or something, so it is very thin, but it is able to carry certain load. So, this thin shell will make your space precious, at the same time it can also take the load. So, what is the property basically? So, it will resist the load, external load, and self weight through its thickness and proper geometry. That is very important. In order to achieve the result, we should also look into the geometry, how the curvature to be drawn for the cell structure and all, and we will get some example to that. Fabric is basically something related to the cloth or membrane kind of material. So, sometimes in order to make structure very light, we use this kind of structure, and already I have given one example of stadium, Munich stadium. There we have seen the huge structure, though that example was taken for a lightweight type structure, but here we can take the same example where like with some steel members and all, the whole area is being shaded with some translucent fabric, and there is so many application of this fabric where it is basically act with a tension. So, the tension fabric to be supported with some cables, and yeah, obviously there will be some support which will help to balance that, and some compressive element structure to be fixed where these membrane or the fabric are tied up. Then catenaries is basically a form that we normally see, that it is basically a member which is draped, means it is simply you can say hang on these two pole. So, if you see the railway track, over that all those electric post and this transmission cable and other thing. So, we have some portal kind of structure. So, this is a catenary structures. I can give you another example also, we call it catenary, that is the queue in station or some of the meeting place. In order to manage the queue, we have certain post like this, okay, and there is some elastic material which may be fixed at any direction. So, this is also called catenary. So, we will see this application in our architecture. Then ripped is something like the skeleton. Okay. So, if you remember, we started with the lecture where we have seen like take example from the nature, like the human body. Though we have some muscles, we have some outer finish, and with some clothing and all, we take it in a different manner. So, depending on the color and other thing, but basically we are stable or we are standing because of some support of the bone, okay, the skeleton. And so, it is true for the some structure where it is very much predominant. Okay. So, every building they must have some structure or skeleton, but this kind of ripped structure is very predominant. We will look into that also. Then arches are very simple. So, different kind of arches may form the architecture. Folded plate I explained with some paper, right. So, if you have a paper and then if you just fold it, okay, so it may carry some load, and when you make it in order, so it can also take a huge load on it. And why it is taking load and all, how it will balance the compression and tension, we will discuss in detail when we discuss about the folded plate structure separately in the class. So, here we will see like some examples under this category. The frame structure is very simple, straightforward beam column composition structure. So, this is something normally we see in any house or something, and it has been practiced from so long. Then the walls, sometimes we have also shown some example where you have very opaque type of quality in your structure, where you have some very less opening or no opening, and walls are predominant to it. So, the walls, some arrangement of walls will create some architecture. So, let us move to each of these category and take some examples and try to understand clear what exactly how this synthesis is happening with architecture and structural form. This is one example, and this is very simple one, a small one like the bus station, okay, a shelter. You can see this, this is maybe the office area, like official thing and all, and people can wait there. This is the bus. So, here you can see the thickness, okay, very thin, and this is giving a form of an arch. So, it is also known as surface structure, because as of the thickness, cells resist and transfer the load within the minimal thicknesses, okay, and that is the advantage of using it. The similar cell structure being used in Sydney Opera House, even in our Lotus Temple in Delhi from India. Now, for that what is required? 2 or 3 dimensional curve geometry and correct orientation. So, to give the support, where to support it, where it should be oriented, how it will counter the weight, transfer the weight, that is very important in this cell structure. And what is the advantage if you see this? So, this area is having no column. So, you can create some kind of interesting space, column free space wherever we require it. So, this is one example, very beautiful example of cell structure. Here we take another two. This is one auditorium in MIT, and this is already sometimes back we have given this example of TWA terminal, and that time we have taken this example as a like form like flying bird or something, but here we are taking this structural element which is very thin made of concrete. So, creating the cell structures. So, they are being supported somewhere and it can create it. So, basically the cell structure, if you just design it with a proper geometry, making the balance, take care of the moment of inertia. So, you can create beautiful space with this, and the material sometimes it may be made of concrete, sometimes you can also think of some other material without compromising that your strength, then stiffness and other thing, and definitely the proper orientation and positioning of the support will give the stability to give you the synergy. So, these 4 A's I have explained here how to get it. Now, come to the fabric structure. So, again it is a cloth like material made of some poly ethylene based material, sometimes high density polyethylene. So, different kind of material to be used in this, and these are being very useful to create your reduce the load of the roof, where it is just a requirement to cover up the area just to protect from the rain and the excessive light or heat. Then we can propose this kind of structure. So, we have seen one example from Munich, that is the stadium, and here it is a ice skating ring, and this is basically a sports center in Germany where it has been used. So, you can see that how it is being placed. So, there are some supports and where this membrane is fixed, and from inside also there are some poles and there are some cables which will connect it. So, it is the tension fabric that resists the self weight and wind load, because for the wind load there is a problem of upliftment of the structure. So, if you have a pitch roof, so there will be some wind. So, this will create some pressure here, and that can make some upliftment of structures. So, we have to take care of this. And now, looking at the form. So, when we discuss this fabric or membrane structure in detail, in detail, so there we will see the different kind of membrane structure. So, here it is basically a conical one, and depending on that we will also discuss about some property of the curve, whether it will take the arch form or parabolic or hyperbolic form. So, we will discuss there. And here it is very beautifully designed, it will take care of the tension as well as the light. So, through this one may have the light, and you can see this the people are enjoying the skating there. So, this is one application of the fabric structure. So, let us move on to the next. It is in again in Arizona State University campus. So, this is a structure, it is more clear than the previous one, where like different posts are being used and cables are used to provide the adequate tension to the fabric. So, it is creating a very interesting shade and shadow and also some space to enjoy, though it is very open in nature, but this is creating a beautiful piece of architecture. If you see from there, so these are all tensioned fabric, and supported by some very lesser thickness cable, though they are having the strength to carry this thing, and you have some support long pole to tie up to create that tension in adequate manner. So, there also we I can mention something about the cable suspended bridges. So, there are many examples in the world. So, that also act with certain principle, but here it is called fabric structure because of this fabric being used in this. So, it is again having the tensile structure in nature. There are some members which will take care of the compression, but overall it is under the fabric structure. Now, move to the catenaries. Already we have discussed that there will be some two poles and a member is just resting on that and it is giving a form of a portal. So, here this is the example of Dulles Airport, Washington DC. So, here you can see like this is a terminal building as because your terminal building should have some openness and you should not really obstruct it with regular number of columns and all. So, here you can see that this is basically a series of such component being placed one after another and then there are some slabs, the catenaries which will rest on this to support. Okay. So, inclined piers support the catenary slab. So, this kind of structure is being seen in many cases. So, here the synthesis happened with the catenary with this. So, overall this is giving a sense of a portal, but as well as it will also create this particular space column free. So, whenever we require this column free kind of structure, we may think of that. So, what exactly happened there? Transfer load to the support through tension. Okay. Roof self weight should exit the wind load because of this kind of long span. There will be, if this is free, so there will be a flow of wind and other things. So, this should have the self weight adequately, so that it will resist against the wind load. Now, reinforced concrete is sometimes chosen as the material because of the property, and again you mention just look into this is RCC, as because this will act with the tension. So, compression can well taken off by plain concrete, but in order to take care of the tension we need some reinforcement as RCC does. And compared to the other example, the Dulles Airport, this is again huge. So, if you see this particular material having the thickness is very small, and here what is happening, this is example of pavilion of Portugal. So, here these two buildings, okay, and their portico being connected with this canopy. So, here canopy drapes between two porticos and it is again open. So, there will be wind blow and other thing, and next to it there is some water body also. So, it is predominant. So, it should have the property to resist against that. So, it is allowed bend to this. So, sometimes this kind of structure is being created to give something like some openness to that span, and considering the scale, and you can consider this human being height. So, take standard height of 5 feet 4 inches. So, you can see the span is a huge span. So, it is possible, it is stable, it is standing there, and this huge span is being supported on this portico. So, this is again another example of catenaries. Now, from catenaries we move to rib structure. Already the way I define that, it is basically very visible that skeleton. So, here you can see, look into the building. So, most predominant, even this is the glass being used in this, but here if you see that there are some ring kind of structure and being supported with some ribs. So, basically if you see this thing and we compare it with our globe. So, the latitude, longitude, this is making basically a skeleton to it, and it is very well designed, and here it is not in a circular form. The inside structure is basically creating a ramp which will go up. So, this is another example where the structure is basically made of steel and it is visible. So, predominant structure, as we define the structural form, sometimes is basically the predominant structural element to the building. Here it is very clear from the picture that it is the combination of ribs and like your circular, the horizontal and vertical ribs to create this rib structure. So, where it is being useful? Like it depends on the concept, how you want to show. Sometimes you may hide your structure within the building, you can only see the overall outcome or the form of the building, or if you require to show the structural element, make it very open type, so you can do it. So, even if you recall the example of Bangkok airport, they are also something like that. So, they have multiple series of this kind of arch form and they connect it, so that while sitting here you can see outside. So, from outside it can form this. So, the same example can be categorized as the open type of architecture. In visually openness is there, but in terms of the structural thing, it is basically the ribbed structure. Now, what exactly it is here? There are few points that generate and define architectural form, although their skeleton character often necessitate a separate involving system. So, what exactly it is? Like to make it, so it may have a separate system to hold it, to make it stable. So, which sometimes may be very pleasant, but sometimes you just do not want it, just some portion of that is of that kind. So, you want to show it or not, it depends on the architect, but in order to give the completeness, in order to get that particular clarity, so it is sometimes create its own structural envelope. Rib structure generally enclose single volume rather than multi-story construction. So, whenever you have multi-story building, so sometimes we just compromise it. So, we will simply go for a small kind of structure, not the high rise with the skeleton, but yeah, definitely in some of the high rise building we have used that with the ribbed structural form, and we put it in grid structure and all. We will discuss that in the upcoming lectures. Take another example, this is National Art Center in Tokyo, Japan, and here it is another example where you see that you have some vertical member structures and you have some wavy structure connecting. So, from inside also if you see, the openness is maintained, but it is giving ribbed like a skeleton kind of appearance from outside. So, it is very predominant to the building. So, I have taken this example under this category. So, vertical but curved ribs support and define the undulating facet. So, here it is creating some undulating effect through the structural arrangement. Now, come to arches. This is another beautiful example of a museum, Paul Klee Museum in Switzerland, where beautiful use of arches and different size and all, it is resembles with the mountain at the back. So, to bring that compatibility with the environment, arch being used. So, basically take this arch form can take various shape, it may be semicircular, it may be parabolic or pointed. So, in Islamic architecture we have seen some pointed arches, and sometimes in later the Felix Candela's design that we have seen this kind of structure where it is basically your parabolic or hyperbolic paraboloid structures, and semicircular is very common in many of the domes we seen in India history. So, there we use the semicircular thing, even in Gol Gambuj in South India. So, there also we have seen that domical structure, and usually meet the ground at an inclination to the horizontal. So, here it is meeting the ground, but sometimes when it is a combination that you have rectilinear form, and then on top of this arches or something in a domical form, the section being used. So, here basically what we are talking about, the example I have given for Gol Gambuz, that is not exactly the arch, that is the dome. So, here we are more emphasizing on the arch form. Okay. So, depending on that, how you create the arch as a door or entrance. So, that is being more predominant in this part. So, let us take another example. This is in walls. So, great glass house. So, here if you see that it is basically a multiple arch in both the direction, creating this kind of structure. And most interestingly, to support this, so they have a ring beam, okay, all along. So, if you see, this has been hidden by the glass, but here you can see that here it is a ring, and then on top of that you have this thing. And in order to support it, in order to have the smooth transfer of the load on top, they have some inclined vertical support, a column which is basically the normal. So, they are making almost 90° to this support. So, it is transferring the load in that sense. So, this is another example of arches. So, mainly predominant is arch, but definitely this being supported with some other format. So, as we have discussed at the beginning, that in building there may be some multiple kind of structural systems, but looking at the dominance will say or will take that in some category. Now, come to the folded plate. If you recall that in some of my lecture, I have explained with a plain piece of paper, and then I folded and create some origami. So, it is something like that. So, this is US Air Force Academy chapel. So, here you see that it is being created with some folded plate, giving the adequate strength and also the column free spaces. So, in order to make this convention hall, assembly hall, some space for huge gathering, we require the space to be column free, so that we can use it. So, here this is the interior of this, you can see easily that it is something like with a fold, like the origami, we create different kind of form, some animals, birds or some other form, and this is the pretty similar. The use of this structure is basically for the roof or sometimes in the wall, and sometimes with some inclined truss we can create the same. So, this is one example of the folded plate, which is basically a structural form, but that also create the architecture of this kind. So, it is making synthesis with architectural and structural form. This is another example of Tempodrom. It is in Germany. This is basically a multi-purpose auditorium, different activities going on, different functions, and again in order to have clear view and other thing, it was mandatory to make this space column free, and for that the options, one of the options was to create it with the folded plate. So, it is giving the strength. So, the ridge and valley, that will have different compression and tension, we will talk into that also in detail. So, this is something we can see that instead of a plain surface or domical surface that we have seen in many of the historical buildings, here it is something which being created with the folded plate, that being supported, those valleys are supported at the end, and it is taking the load, it transfer the load to the members and solve our purpose to create the space as the way we want it to create. And depending on the space, depending on the requirement, the volume, definitely design will change. So, this can be also used for the warehouse. There we can have this kind of structure, okay, and we support some of the area. So, wherever we have this valley, So, ridge is this top portion and valley is the down portion, okay, for any mountain, and this is pretty similar to that. Concrete can be used to it, and some of the small gallery and all being made with wood. So, when we discuss about the structural materials, we will again look back into this to create different kind of form, what kind of material is suitable. So, we are coming towards the end of this lecture. So, here we talk about the frame structure. So, again it is a combination of the beam and column. This is one example, the La Grande Arche in Paris. This is also called frame within frame. This is very good building, we all appreciate it, but basically the fundamental thing is it is being made with some orthogonal skeleton structure, being beam column combination, and it is sometime also very easy to make, but nowadays we should not say like easy or very tough to create. Everything is possible with proper execution, proper selection of the material, technique and available technology. But here this form is being created with a frame where like you have a series of column, and then it being supported with the beam, then top of that again it will go on. So, it is making a skeleton. So, normal housing also we see those buildings are of this frame structure, but it has some limitation in terms of the height. So, when we discuss about the evolution of high rise building, there we will see that when height goes up, so along with the gravity load is the self weight acting towards the ground, the center of the earth, and there is another called lateral load like wind and other thing. So, the gravity load and other thing is can be taken well care of this, but when you go vertical, as we have seen in the load, that with the increase of height, wind load, wind pressure will also increase. So, there we have to support it with some other advanced technique. So, we moved from frame structure to the tube structure. We can also add some structural bracing to give extra support. So, anyway we will not discuss it now for the like in more detail, we will come to that how to get that thing to get the desired height of the structure. So, move to the next example. This is example from India, Mumbai. This is a hotel building, again is very simple. So, made with some column, and you can see the visible thing is also showing visually the grid form. So, this is also a example of frame structure. Now, this is in the last category, that is wall, where the wall or structural walls are capable of participating in the integration of architectural and structural form. So, basically if you see that it is a series of walls mainly, okay. So, that is very predominant here, though some part of that we have some stilted column and all, but overall it is giving you that particular sense. And look into that, if you see this kind of this side elevation, there is hardly any opening to that. There is a sleek opening here and sometimes in this portion also, but it is not the case that all the time we will have this opaqueness. Sometimes also we can achieve some degree of transparency with this wall. So, proper combination of that, there are examples of Louis Icahn buildings and all. We will also discuss during that detailed discussion on the wall and all. So, move to the next example. This is Saint Anger Residency in France. Here if you see, this is something like looking at the building, it is basically the wall, okay, the wall all the side, but as I mentioned that you can also create some transparency by creating or providing some of some transparent element to it, because this is the opaque. So, opaque transparency you all know, like opaque is something that you cannot see through, transparent where you can see through. So, here we can see that this glass, use of glass can give you a visual connection for the people who are staying inside to the outside world, but here it is predominantly the structural form is the wall which is creating this architecture. So, in this we are now to summarize, and here like let us just the way we have discussed in this presentation, we know that what is the form. Your form is shape, so 3D, okay. And then further we discuss architectural form. So, not only this is basically outline of the building, okay, but plus some other architectural aspect, okay. Now, next to that what we have also learned that structural form. So, here what we said that which is the predominant structural system of the building, we call that or consider that as structural form. So, from that we just come to a conclusion that it should be a structural system rather than a structural form. And then after that we also discussed about 4 S's of structure, which is very important. Number 1 is not in particular order. So, one is your strength, then you have your steepness, then you have stability, and then the synergy. These 4 components are essential to create it. And next to that the synergy, the synthesis between architectural and structural form depending on the predominant structural system that is installed to the building. So, based on that we have 8 categories. So, under 8 categories what are those? So, like if you can recall, the first we started with the structure, just not in order. So, let us start with the fabric structure, then you have cell structure, that was the first one. Then you have also discussed the catenary, okay. Then framed, then we have called ribbed, which is skeleton type, then you have arches, and then you have folded plate, okay. And then last but not the least we also call discuss with the walls. So, with all this we create a particular predominant structural form which is visible in our architectural buildings. We have seen many examples and there are many more. So, I advise you all, like I have only given you few examples. So, depending on that you also try to explore more examples, and in some forum we will also discuss it, like how to define it, which is the predominant of that building. So, I love to see those questions and those discussion. I am looking forward to that. But all these things, like sometimes it is predominant, but at the beginning of the lecture we start that a building may consist of multiple structural systems, right. So, they may create sometimes something different, like not coming into the category, it will just create some contrast, okay. Out of that we may have a building like this, where it is very tough to define or put it in the category. Somewhere it is in a combination of the frame, or sometimes it may be the cell structure, some part of that folded structure. So, it create beauty. Overall we appreciate it, not a particular dominant structure, but overall composition, creating a contrast, creating something very beautiful. So, definitely we are really interested to look into that, and with that the upcoming 2 lectures, basically the single topic that will discuss, that is connecting structure and architecture. So, here we will see different kind of where sometimes structure is predominant, or sometimes your architecture is predominant, sometimes it followed, sometimes it is some unorthodox or something not orthogonal. So, we will see that. So, that is that will be our lecture number 6 and 7, connecting structure and architecture. and these are the reference. So, you can I have added one more example, that is a book written by D.K. Ching, Architecture, Form, Space and Order. You can go through it, and I have also given the references for all the image sources. You can go and get more detail. And again I would like to thank you all to take part in this course, and till the next lecture, bye bye. Thank you.